As usual, waiting for Twitch to catch up. And any second now. Okay, I am live. Hello everyone, welcome back to the stream. If you haven't seen the announcement on social media yesterday, this is a slightly different stream from usual. Mostly because it's starting 4 hours earlier than usual, because I want to get a very long stream done today, because this week I am starting the first big refactor of the project. Last week, we got most of the IR lowering down in basically a week, which was very unexpected and very pleasant. However, in doing so, we found a lot of situations in which we end up having to do lookups to old data, and we end up having to have internal compiler errors if that old data doesn't match the assumptions we already have about the things. For instance, if I go back to lowering, we'll find a bunch of things such as, let me look for an example. Here, for instance, of like, oh, we found something that isn't a type, or we find a definition that didn't match, despite the fact that at that point we're past the analysis, and we have already checked that all of those things are consistent. This is why here there are internal compiler errors. Somehow our internal state did not reflect the things we had already checked. And the reason for this is the output of the analysis phase does not capture the things we needed to capture. It does not reflect that information, meaning we have to check it again. So, inspired by this, with the benefit of hindsight, since what was so difficult about the analysis phase in the first place was to figure out what shape the output should be, I think today we're starting a refactor, which is going to take a long time, hence starting with a big stream to get as much as possible done, to go back to the analysis and fix that issue. At the core of it is the way I've been doing the output. We have this big AST of things, which is what the output of what we passed, but it is parameterized by a phase, pass or resolve, that decides, okay, what do we change based on what state we're in, basically. And some example would be the kind of a thing pointed to by a name. When we have just parsed something that's just a path, we found at a.b, or like a, or just foo or something, we don't know what that thing means yet. However, after resolving something, then suddenly we know that it has, this points to something specific, a role, which in turn is something that will tell me, well, that thing, that path we had found, is actually a top-level declaration, or a built-in type, or a built-in function, or something like this. Now, the problem is, if I look at how it's used within the AST, it's used for the path info, which is the thing that accompanies a path that we have passed in the input, and is this thing. It is the name and the parameters. But that means that in the output of our analysis phase, when we have gone through all the paths, we have resolved them, we have found what they point to, and so on, a path expression, in the case of an expression, is still any path info. Not all paths are valid here. In the path expression, this must be a local variable, a function argument, maybe a constant. It can't be, a type. That makes no sense there. We have already checked that. But since the output of our analysis, a path expression, is any path, we don't have that information in the output, which is why when we do the lowering, we have to recheck that information and be like, well, sure, we have a path that we know what it points to, but is it a valid one? Hence, the reason why I want to redo this, I will keep this idea of having things parameterized by the phase, but I will use it with a very different granularity now that we know what we need. Down the line, if I end up cleaning more than just that, there's a lot of things I want to redo in the analysis, but I will let what the output should be guide me into this refactoring. So that's the plan for today. We go back and we fix the analysis so that we can have a more solid foundation moving forward. It was not an easy choice because we're so close to having the full pipeline be able to run, but I think it is important to use this benefit of hindsight to go fix things. So yeah, let's go. And the plan is for this to be a roughly 7-8 hour stream. I'll probably take a break for dinner at some point. Okay, so the main thing I want to do, and again, this is going to break absolutely everything, is I want to go back to this and I want to split it into two files at the very least. I will want to have the input and I will want to have the output. And that's because several of the things will just not be the same on each side. I will for now remove all of the pretty printing, which is gonna break a lot of things. I'm gonna move it elsewhere for now. There we go. Which will break all the tests, but again, since we're just starting with a big refactor, I'm okay with this for now. Because the goal is to get something a bit cleaner. Now, no, lenses are meant to stay pretty, is what goes away. There we go. I hope I didn't remove the wrong thing from this one. I might have removed the lenses by mistake. Okay. And the lenses will have to change anyway. Okay, so let's start with what I want for the output. There's a lot of things that here are no longer required and that I want to change. For instance, if I go to the top, I don't think I really need to care about a definition anymore. Like keeping this kind of definition where we have something like, oh, this identifier points to that. We will probably also want to redo the interface, but we probably don't need that really. We probably only care about this is a type, this is a function, this is a symbol, like what the result of it is. Unless we want to keep this as part of a temporary thing and just not in the interface. For now, let's not remove it just yet. I think the main big thing will be we don't want to have a path info, we want to have a type. We will want to have some kind of type that will tell us what the type of something is. And then we will want, for places for values, we will want to expand them instead. So we will want, I think, a type. And then a type in the output will have to be, I have to be careful there, because of generic functions, there will be situations where I need something to be typed, but it will still need to reflect the possibility that it is a unless for generic functions I don't do that. Now, okay. For now, let's say that a type is either a enum pointing to an enum info, or it is a struct pointing to a struct info, or it is at the core there is int, well, int type, I suppose, boolean type, character type, oops, enum type, struct type. And we will probably need, although I don't know yet how that's going to work, perhaps we will use another type parameter here to restrict this. We will probably need placeholder and type parameter with an identifier for some contexts where the type is not fully known yet. But I will probably want to do something where this is parameterized by like a state S, and this has an S value here, and we will probably want to do something like generic type being a type with this, and type concrete type being a type with void. Since void cannot be inhabited, that means that something is a concrete type, it cannot be a placeholder or a type parameter because it would require having a value here of type void, which is possible. Meanwhile, if it is a generic type, then it could be a placeholder or a type parameter because then this would become a tuple, like a unit thing, which exists. So that might be something we end up doing. Okay. This goes here. In this logic, although this might end up creating a lot of cycles and this might be a nightmare, but I think this is nonetheless the right thing, type alias info will contain the actual type it's pointing to, right? And in the context of... The thing is, do I need the definitions? I might not need the definitions is the thing. I don't think I do. I think when I am done with output, like analyzing a thing, keeping the definitions of something isn't something I'm interested in. I just want to know that name points to a given type. So I think I don't need that in the resolved version. For a type alias, then do I still need the type alias? I probably do, actually. So maybe I need a definition for the internal things. That will be probably an internal aspect of this. This will not be part of the interface. But I will need to know, okay, this thing points to a type alias, and therefore it... I will probably use a different type of definition for this. But I will probably need to keep around a type alias info just because I will need to do parameter mapping. Do I put that in a type then? Does that become an alias S, which points to with a type alias info? Maybe I do that. Because that is something that makes sense. Yeah, I think that makes sense. While I'm doing the resolving of something, I do a lookup of something for a type, and I get something that happens to be a placeholder, type parameter, or type alias, because I am in the process of resolving, but the output must contain an actual concrete type, and therefore those things become void. Yeah, I think that that is something that makes sense. And so for a type alias info, I think the name is no longer required for the output. The parameters still make sense, I think. We still need to have that. We need to know what type we're pointing to. But in the case of generic type, how do I reflect type parameters? It would be in the struct info, something like this. So here, this would be... a value is fine, and this points to a generic type. And we have the mapping, where we'll have a map from each... Hello, how are you? I'm starting a lot earlier because this is time for it's day of a big refactor. I'm changing everything in the analysis. Specifically, I don't like the way the output is. The output being weird was a real source of struggle when I was working on the analysis. And last week, where we've done all of the lowering to IR, the fact that the output of the analysis did not capture the information of like type safety and everything very well was a pain in the ass. So I am rewriting the output, and from that I will change everything basically. And so the mapping will be for the arguments for the type parameters of the type we're pointing to, what generic types are associated with it. it's going to be a generate type guaranteed here because at this stage, the type alias only exists when we are in the process of resolving something. At the end, we will only have those things. That's not entirely true, is it? There's one thing I need to take into account here, which is no, I think type alias doesn't make sense here. The only place where type parameters like this make sense would be for a struct, and therefore the struct info might just contain. Yeah, I think I'm going to change this. I'll think about it. Enum info is just going to be purely. I'm tempted to just replace that as just being this is a list of identifier. Yeah, the plan is to have a very long stream today with a break for me for dinner at some point, but like to try to get as much of it out of the way as possible. There are things I know I want to achieve, and there are things where like I know what shape it should be roughly, but I'm gonna break everything and we'll see what shape the pieces are in the end. So type alias I'll have to think about. I'm not even guaranteed like I want to keep this. Enum info goes away in the output. Struct info might make sense. It depends. I think it depends. It depends how much layer of indirection I want to keep in the output. I think I would really like. Okay, I'm going to start with something else. I'm going to start with the expression, because the expression is going to be where there's going to be so much of a change compared to what we have at the moment. For instance, path expression will just go away. That is no longer going to be a thing. Instead, I'm going to have local variable expression, which will point to an identifier, which is the local variable. I'm going to have reference argument expression, pointing to an identifier as well. And that's going to be basically about it. There's also going to be function name expression, which will point to the unique name of a given function. And I don't know if I want to separate this into also built-in function, because built-in functions might be different. But I think I want to make the distinction between built-in functions and non-built-in functions go away at some point. So maybe this should be enough. Okay. And since here I will be in the context, I will have a different kind of expression for the output. I no longer need the annotation kind of thing. I will probably be able to just replace all of those annotated expression of thing by just typed expression, because I will know for sure. So a field access expression will be. Do I want to keep constant? No, I think I still want to do the full constant inlining for now. So a field access expression is an expression and an identifier. That makes sense. Here, a call expression, I think, will have to be a function name. But we can probably. It will be typed. It will be typed. The type doesn't. Here we want just the name, probably, and we will probably want a function type. And the arguments will be the type expression of the arguments. Hello, how are you? So the idea is like here again, we remove all of this path thing that was really annoying in the lowering phase, and instead we replace this with like much more concrete things, since now we have control over the full thing. Arrays will just be typed expressions. How much lag was that for you? It should be like a few seconds at most, right? For a struct expression, we are probably want, and this is where it gets complicated, but this is still, I think, where we want. We are probably going to want to know the name and the struct info. We are going to want to build, to like consolidate at that point to reflect in the output AST to like bundle all of the information we need in the output AST to remove the need for a bunch of lookups in subsequent phases. That's really the gist of this change. And here this becomes a typed expression again, because now we have the function type built in to a call expression. So we know we're calling a function, we know what the name is. And we're here we have a struct expression. We have the struct info bundle with it. And do I want to actually build to do that for the field access expression as well? I'm almost tempted to do that. Like a field access expression, by definition, is something that extracts something from a struct. Of course, given that this is a typed expression, I will have the struct info in the type, but doing so will require like still to do more checks down the line that I don't need. I could just also name struct info here and bundle that as well and keep bundling the information to avoid having to do lookups later. Those don't need to change. A reference. Do I want to keep reference expressions? Because the reference expressions are an artifact. So, sorry, I had missed your question. I am doing today is a special stream. I'm starting a lot, I'm 4 hours earlier than usual because I'm doing a full refactor. Last week, we basically did a solid 90% of the lowering to AR in a week, which was very nice after like months on working on the analysis. But in doing so, I really like got the benefit of hindsight on all the things I did wrong in the output of the analysis. Choosing what to input, what shape it should be, how it should be structured was really a thing I was struggling with during the analysis phase. And now that I see how it's used down the line in the AR lowering phase, I realize really the mistakes I've made. So, but again, benefit of hindsight. So I'm going back to the way the AST is shaped, and I'm changing the output of the analysis phase to have something that does capture the information that I need a lot better. In doing so, I'm going to break the entirety of the analysis phase, and I will have to redo a bunch of things, and that's fine. I'm like this week is basically going to be, and maybe also next week. Yeah, I don't know how long it's going to take. Is going to be fixing the analysis to have something in the output that's a lot. Well, a big example is like since I'm going to go back to here. I'm using the trees that grow approach where like all of my types in the AST have a type parameter that indicates like what phase we're in. And then I do like type families, type mapping to like, oh, well, what is a path name when we are just in the past AST? What is a path name when we have resolved the AST? That kind of stuff. And at the moment, this basically means I have a path info that contains like, well, this is a path. What does it point to? When we've just passed the source code, we don't know yet. It's colon B, or it's just like the name foo. We don't know yet what that thing is. After we have resolved, we know what each path points to. It points to a top-level function, it points to a struct, it points to a local variable, it points to a type parameter within the function, that kind of stuff. However, that information is important, but when I have something like, for instance, a path expression, this part of the expression, like as an argument to a plus or an argument to, I don't know, a index expression, that's a path. When it's passed, that makes sense. I don't know where the path is. And after I resolve, okay, I have a path expression that contains the path info that tells me that was a function, that was a local variable, that was a type, whatever it was. However, not all of those things are valid. For instance, I can construct, it is a valid value in the sense of the Haskell thing, to construct a path expression that is resolved after resolving something, after like doing the analysis of a function, that contains a top-level function. and have that as the left-hand side of a index expression, which makes no sense. So this structure, with just the very basic mapping in the path type, allows me to represent expressions in the output that don't make sense. And since they can be represented in my Haskell type, it means that in my subsequent phases where I have to do things like translate that resolved AST into something else, I have to be like, well, that value technically possible, but doesn't make sense. So my lowering code is littered with, well, internal compiler errors. We got a value here that is technically possible, but doesn't make sense given that we've already done name checking, type checking. So instead, I'm changing the granularity of this type mapping from like pass to something, from resolve to something. So like I have path expression in the input. That's a path, I don't know what it is. But now in the expressions of the output, I have local variable, reference argument, function name, and so on. And rather, I no longer have just like, that's a path. And therefore, that means when I do the lowering later on, I will not have to be like, well, that path, is it something that's valid or not? I now only have valid possible values here. That's the goal, at least. And so I need to just continue going through this. A struct expression will capture the name of the type, the struct info. So it is bundled with it. I don't have to do a lookup of the struct info, which means I will have the full thing. Which might, is that required? Do I need the struct info for this? It's probably, do I need that for the lowering into AR? When I lower a struct expression. No, I do get the, well, I need the information. Yes, I need the type information. So yes, I will need to know the struct info. Okay. Okay, so that's, so yeah, basically changing the shape of the output to capture the information I need, which breaks everything. I don't think I need to keep reference expressions at the moment, because references are a very weird quirk of the way the language is designed. They're not real references, they're not pointers. And I think I don't need to keep them. I think they only need to exist in a language to make call types explicit. I don't think they need to be reflected, in the output of the AST. So now this is a lot easier. A cast expression, now this just needs to be a type. And here is the interesting thing. I have something I need to figure out, which is when I deal with a concrete function, I know that the type here is a concrete type. A cast cannot, if I'm in a function that has been resolved, has been analyzed, is done, then it cannot be a generic, it cannot be like a type parameter. It cannot be cast to T, where T is a function template parameter, because at that point it has been resolved, the type is concrete. But if I am doing the analysis of a generic function that has not been resolved yet, then there could be a type parameter. So now, how do I reflect this? Because I will want the output, the real output here at the end, to be a concrete type. But will I want... But I will probably want to have an intermediate state in which I represent things slightly differently. It's the same idea that I have here, where my type has a thing that allows me to decide, is placeholder a thing that's valid, is type parameter a thing that's valid. Does that mean I need to have, even within the resolved thing, I need to have another subdivision of phase of like concrete versus abstract, basically? Probably. That would probably make sense. The other option would be to not. The other option would be to change the analysis even more and would be to introduce a third phase and first do the name resolving and no type checking, and therefore replace every single and basically have what was the previous output as the intermediary phase, basically, not do any type checking there. So no type checking, no constant inlining, purely name resolving, and then having this output at the end. But I don't think I want to do that, because if I do that, I go back to the problem of some of the information captured in the first phase is lost in the second. I need to think about this for a second. Unless, no, this could be an idea. This could be an idea. Maybe this becomes, maybe I change things even further then. And I break the analysis into resolving the name and then doing the checking, basically. And that purely means that might be a better idea. That removes all of those problems here. Okay. But that means we break even more things. I think I'm okay with that. But that's gonna be fun. Okay. So that means that what I have here actually becomes not part of the AST. Or it becomes a third phase. Yeah, I mean, it's tempting to just like restart from scratch, right? But I will try to save as much of the code as I can. So basically, I do resolving, that transforms into, and then I do a third thing, which is the checked thing. So this becomes checked. And here, as a result, when something is checked, there is no longer any possibility of any of that nonsense. Type aliases are no longer a thing by the time we are checked with things, probably. Oh, hello everyone. Struct info will probably remain, but it might change also. It might be very different by the end. Const will probably just entirely go away. Hello everyone, working on the compiler at the moment, from a made-up language made to look like Rust to an esoteric language at the end. I'm targeting Pete specifically. And today is kind of a weird stream, so welcome to a peculiar stream. Last week, of all the phases of the compiler, we did most of the lowering to AR. So we've already done like name checking, type checking, and so on, and like generate an AR that's based on the LLVM AR. But this week, I'm going back to the analysis and I'm fixing it. There was a lot of... oh, wait, do I still have advent of code in the stream tags? I thought I had fixed that. Yeah, I still have advent of code 2024 in the stream tags. Good point. I will fix that. That is fixed. Thank you for pointing that out. Because yeah, I mostly stream the advent of code usually. But this year I've started another project, which is this compiler project. And yeah, this week is the big refactoring thing where I go back through the previous analysis phase and I'm breaking everything. Yeah, I know, my accent is a dead giveaway. Well, not exactly LLVM, but close to that. One of the goals is to try to get something, to get the AR of our made up language to be somewhat compatible with the LLVM AR. To do, yeah, I am from France originally. I moved out 10 years ago, but I will never fully lose the accent. And yeah, the goal is that our IR, despite being tailored to our need, at some point I will do an export of it to the LLVM IR so that we can try to compile the backend of our language with LLVM to compare with our own backend for test purposes, basically. But that's not done yet. At the moment, I am doing a complete change to how all of the analysis works. So I am breaking the entirety of the code. It's going to be, nothing's going to compile today. Specifically, I'm changing the output so that the output better captures the type information we have gathered along the way, so that I avoid having to do redundant checks in subsequent phases. So here, const info will probably entirely go away for the output. That's no longer required. Function info will probably not be... It's a very European stream today. That's nice. I think function info is just going to completely go away at this point. Function type will have to remain unless I just put function type as part of this, which would also make sense. A function type is something that returns maybe a type and takes arguments, some types, and therefore this goes away as well. Unless I do that as maybe as an archetype and I need to capture the reference information. So yes, this will be function arg type, which will be by value or by reference. Okay, let's break everything. Let's remove all of the instances. We are gonna have to redo all of that anyway. Function type goes away. Struct info. Do I need that? I might not need that. In the sense that, like, when something is resolved, I will probably just need... The problem is, like, generic types, of course. That's the main thing. However, I think in the output, I don't care about the actual types. Like, this was type foo declared on this line in module bar. I just care about this is a struct with those fields. As a result, I think I don't really care about type parameters in the actual output. I think the only thing I care about is basically this. So I think I only care about having a non-empty list, which is tuple of identifier, the name of the field, and the type of the field. And this is getting extremely close to the type that we are using in our IR, which means we will have the translation from this to the IR will be basically transparent. And we might just be able to remove it entirely. So this goes away. This goes probably away. I'm going to comment it out for now. I'm going to remove it for now. We'll put it back if that's needed. I will still need statements. That hasn't changed. I will still need statements in the output, and I think those will be the same. So I will still have if info, for info, while info, let info. Those I could almost consider reusing across... I could even consider reusing across different stages. I will not, however, just in case I end up needing different information. The whole point about this refactor was I tried to use the same type across different phases, and I realized that doing so, I was not able to capture the accurate information I needed. Let's duplicate the types, and if maybe down the line I realize that duplication is not required, I can deduplicate them. For now, let's do this. And that is a maybe typed expression here, because since I am no longer requiring all of that logic, I can, of using the same type across different phases, I can be explicit about what we need. And here I should be able to deriving show and so on all of them. Okay. Do I want to keep block? Yeah, block makes sense. The question is, do I want to keep annotations on statements? I think I will need annotation on statements. Although now I know exactly what it is, I don't have to keep the parameter. I think I will still want to keep location information on statements on the output. And the only reason why I will need location information that late into the processing is because I do the control flow analysis as part of the lowering to IR. When I lower to IR, I basically generate the graph of each function, of the control flow of each function. And as a result, everything such as unreachable code or this path doesn't have a return, all of this will be discovered as part of the lowering to IR, which means I will probably want to do some of the error reporting of like, hey, this thing is unreachable as part of that phase. And to do that, I will need to have the location information. So I think I'm keeping the location information in the output of the analysis. Okay. If info no longer requires the type parameter, and I think otherwise this is all the same thing, that's a typed expression that is just a block that is maybe an else info. And an else info is either an else if with an else info or an else block with a block. For is gonna be, yeah, it's gonna remain the same. This is interesting. Here's an example of perhaps I could change things here to capture more information. Because here, the range expression of this thing is any expression. However, I know that's not true. I know that in the output of my type checking, although I don't have support for ranges yet, when I have support for ranges, I will have checked that the range of values on which we're iterating is indeed a ranged thing. So maybe instead I could have something that purely captures either range inclusive expression or range exclusive expression and captures the type of the arguments. So maybe I can do that. So it could be something like this for a variable type, which will be a type. And then expression will be a range expression. And the body will be a block. So I will need to remember to introduce a range expression. That's new. Yeah. Okay. While is going to be even simpler. That's just a typed expression here that we know has to be a Boolean, but that will have already been checked. That's fine. And a block. And the let, what do I need to keep in the let information? Here, typically, I have a maybe type because in the past version of the AST, the type is optional. However, I will probably want to capture, I don't need to actually. In the output, I don't need to capture the type because it will be part of the typed expression. So here, I can just remove that entirely. Okay. And deriving show as well for debugging purposes. And now our expression that we are changing. I might change something. I might introduce range expression here for the sake of using it in a for, and it's either a range inclusive or a range exclusive expression. And that means here I can remove the range thing that already removed, and instead have No, I'm going to put it here. Range expression that has an argument, which is a range expression. Okay. One big thing I'd like to change as well in this to capture better information would be the left-hand side of an assignment expression needs to be an L value. It needs to be something that can be assigned to. At the moment, again, because we are using an LST that's based on the past input and not something that captures the output properly, this is just like a typed expression, which means we could have a function call on the left-hand side of an assignment. That's something that is wrong, that the type checker and name checker, like the analysis would reject, but that would still be possible to construct. So I think what I want to do is instead having like an L value expression here, having a different type that only reflects the things that can be assigned to. And that would be a different type. And a different type, L value expression. Actually, I'm going to move this one below as well. And an L value expression can only be the composition of L value expressions. So it needs to be, at the root of the tree, it needs to be a local variable, L expression, which is just pointing to a given identifier, or it needs to be a reference argument, L expression, which is also an identifier. I am almost tempted to see, can I just make that, say that like a subset of this is an L value expression. Parsers are extremely fun. Have fun with this. Parsers are a great joy in my experience, especially recursive design. I think they're just fascinating to write. And like writing parsers library, like figuring out how parsers work, I find that extremely fun. Yeah, it can be scary at first, for sure, but it is a fun exercise. Like for instance, what I'm saying is basically this L value expression is going to be a subset of this. Do I make a subset which is like, hey, that thing is potentially an N value, and I think I'm going to do that. Part of an expression could be a L value expression, which has an L value expression. Well, the thing is, like, you know, I can't make a generic statement, but like, if you don't find it fun, like I hope you find fun in the thing you're doing, is my point. Or I hope you manage to find the thing in that domain that you find fun. I find Haskell compilers, parsers to be extremely fun. That's why I'm doing this. And that just means I think the problem of L-value expressions is that it's a slightly misnomer, because those might appear as R value. It's just like expressions that have the capability of being L values. They don't have to be. So reference goes away. It goes here because now this is local variable reference argument. Those are things that can be L values. What else can be an L value? A struct expression cannot be an L. It can actually. It can be at the root of an L value, because although this would probably be... No, it cannot. It cannot. I'm wrong there. It has... An assignment has to be assigning to something that is pointing to by a name, so the root of the tree of assignment has to be like a name, like a local variable, an A, something, and then it can be a composition of things that access something within it. So it could be field access, and it could be index expressions. Because assigning something to A.B makes sense. An index expression also makes sense. And I think nothing else is something that can be assigned to. Yep, so that should be all of it. And just that, we already have something that's different from our AST, our parsing AST, but has a much better, like is much more convenient, because now when we are in subsequent phases and we see an assignment, we don't have to check like, oh, it's any expression. Did our type checker mess up and let a division be on the left-hand side? No. Now the only possible kind of value of an assignment is an L value expression, which is itself, and those are actually L. Oh, do I want to capture the type? I probably want to capture the type. So this probably needs to be some kind of like typed L value expression, which means I might want to make typed something that decorates the expression. So I am going to replace all of this with typed expression. Because I will want to also have that kind of decorator for L values, which are also a kind of tree of values. This is just a type, so it's going to be a typed range expression. Do I want to rename this expression as being like, is that an R expression actually? Is that like a R value expression? An R value expression can contain an L value expression, but not the other way around. I think I might want just to keep expression as being the root name for this, which captures the everything. But still, this becomes a typed L value expression. Typed expression on the right hand side. Oops, not what I meant to do. There we go. Okay. What else do I need to change here? Typed expression now becomes with a space, and this becomes a typed L value expression. I do upload everything to YouTube. You can find a link to the second channel on the GitHub page of this project, but I do upload everything to a secondary channel, which if you give me 1 sec. Ah, that's not the right link. There we go. That is the correct channel. Let me go back to Twitch. All of the streams are here. I don't always upload very quickly because sometimes like the export takes a while, so I'm usually lagging a week behind, and I've missed 1 or 2 streams over the course of the project, but otherwise, except for the few things I've missed, the entire history of the project is there. And it is a goal I have with this project, which has been sometimes frustrating, but I do not write any code for it outside of the... thank you. I do not write any code for it outside of the streams. The idea of this was like, even though I'm writing a compiler for like a made-up language targeting an esoteric language, so like with little real-life practical applications for the actual code, I wanted the entirety of this project to be live. So there is no code written outside of the streams. So you can see all of the mistakes I make. You can see all the times I change my mind. You can see all of the difficulties and choices that go into making this. Yes, it is. It is like it really depends on what you're trying to achieve, right? Like I am here, I have a very concrete goal. Actually, since it's a bunch of new people, I'm gonna show it. My goal is to translate something that looks like Rust, that looks a bit like this. That's an example file I've been using for debugging the lowering into AR the other stream. And the goal is to turn it into the Piètre programming language, which looks like this. Piètre is a esoteric language in which the source code is an image. and it's the transition between blocks of pixels that encode instructions. So that's the goal of this. We're turning Rust into images like that. This sample program was generated by the backend of our compiler. It does nothing. It prints 2 characters and it exits. That's the end of it. But you can see the shape of it. Those are the functions, like those vertical blocks, and all of the stuff around is the routing of addresses. Because I have planned for it's purely a stack-based language, but I have planned for unique addresses for the language, and I already have the linking phase of we have a bunch of bytecode for the functions. We assign unique addresses for the things so that we can know where, how to jump within the image. And I have the assembly, as in, okay, I have linked all those things together. Let's generate an image. What is missing at the moment is the code generation. We can lower all the way to the AR, which again looks like the LLVM AR, but very much simplified. And from bytecode, we know how to generate an image. We are missing that code generation in the middle. But today I am back to the analysis because I don't like the way I've implemented it. And I see, with the benefit of hindsight, the mistakes I've made there. So I'm fixing those mistakes. Again, now the left-hand side, for the output of the analysis, the left-hand side of a sign will be an L value expression, and as a result, there is no longer any risk of this capturing something that is impossible. Now those are back to being a typed expression, so I need to add a space there. But yes, since I am targeting something very specific and also very practical, I want to make an image, then there are a few places where I will take shortcuts. My built-in times are int, character, boolean, and they all take 1 space on the stack, right? There are some shortcuts I can take there. However, I still want to go all the way to I have generic functions, I have type parameters for my structs. I still want to try to have some complexity in the language. So even though there are things that are simpler than a real programming language, well, for some value of real, a practical programming language, there are places where I accept some simplicity. Here, as a result, and this is where it becomes interesting, that doesn't work. That doesn't work. I cannot do the thing where an expression is something that is an L value or something else. That doesn't work. I will need to keep the L value expression and the regular expression separate, because a field access expression, its left-hand side, doesn't have to be an L value if it's not in an L value context. So I will have to go back, bring this here. Reference argument, field access expression, index expression. Those remain the same for the generic expression type. For a field access, I will still want to have a typed expression. Okay. And as a result, the L value expression will have to be different. It's not the first time someone says that about the stream rate, about the bit rate of the camera, and I don't know what it is. I suspect it's an OBS issue because it happens randomly every now and then. Let's try. No, it's supposed to be 30 FPS. Yeah, I don't know. I think something is wrong with either my camera itself or with OBS. I'll try to see if I can figure out something for next time. As long as the code is readable, I argue that's the most important part. But yeah, that's a bit annoying. So yeah, basically we'll have a completely different tree of things here. But to make sure that when we have an L value, we only have things made out of a tree of L values. So this becomes a typed L value expression. It could, yeah, I guess Twitch could be doing some compression as well. That's possible. Because Twitch says my bit rate is excellent in green. So hopefully that's still good. Do I rename L value expression to L expression? No, it's going to be too hard to distinguish. Let's keep L value expression. There we go. So now, again, we have duplicated a bunch of things, which downside, the upside is, now on the left-hand side of an assignment, there cannot be a multiplication or a division. It is impossible to construct a value like this. On the left-hand side of an assignment will be a local variable, a reference argument, or a field access from something which is itself one of those, or maybe a field access. So we can do a dot b brackets 3 dot c equals something, but we can only in the output construct valid assignments. Are the cursor as well? Yeah, okay, so if it's the whole stream, then yeah, I've noticed that on some streams that sometimes Twitch does some compression. My bitrate continues to be good, so it's probably on the Twitch side. Sorry about that. Okay, so what are we missing here? We are gonna missing a few things. Path info goes away. Lenses will have to stay, but we will decide which ones we need afterwards. Okay. Typed expression has become up like this. I guess I don't even need the typed expression for an if block. It has to be a Boolean anyway. So might as well just not even capture information I don't need. Likewise for a while. Okay. And I guess I could do that for the let as well. I could do the let type is the type, and the let value is the expression, and I don't need to have the annotation because the type is already there. Okay. That's a lot better than what we had before, and we are just missing typed. So something that is typed is just... Do I want to name them? Yeah, I guess I do. Type... How do I name that field? Or do I not bother with naming the field? Type is just a type and the a value underneath. And that's gonna be... deriving the usuals. I probably want show as well. Okay. What else am I missing in the output? I think for the output, that's all I need. I don't need anything else. And I will probably want to keep some stuff like, oh, this name points to this kind of declaration. But I think for the output of... Yeah, I think this is probably what I need. I'm going to remove all of that for now. And this is going to be the checked version of the AST. Or do I consider that this is no longer an AST and this is the interface? Maybe, or maybe... No, I think I'll keep interface as a separate module. Okay, so now I can go back to the distinction between passed and resolved. And I think for those, as a result, since now I'm introducing this new phase, I'm going to keep what I had before, as in keep this thing with the type, the parameter, where the gist of it is basically I'm gonna do all the name resolving first, and then but doing just the name resolving is gonna be, that means traversing everything twice. But traversing everything twice, the upside is I don't need to have in my output things that capture things that don't make sense. I think I want to do that. I think I really want to do that. So that means, do I need to distinguish anything between the resolved version and the past version? Or is it just the same? I think it's mostly going to be the same. So that means this can probably move to... Let me think about this for just 1 second. So I'm saying the difference is, the only difference will be annotations will not change. So annotations goes away. We keep exactly everything the same thing. The only thing is name resolving, basically. Yeah, okay. Let's do that. So basically, we are breaking the analysis into two phases, a resolving phase and a checking phase, which is something that I didn't want to do in the first place, but I think has so many benefits in terms of how we represent the output that it's worth doing. Okay. So annotation goes away. But I want to keep the AST phase. Give me 1 second to think about this. Do I just want to do fully resolve a module first, where all the names are resolved, I know what everything points to, and then I do the checking in the second phase? I think I do. That's gonna break everything. We're gonna have to rewrite the entirety of the analysis. That's fine. That's fun. Purity can probably go away. We probably don't need that anymore. Or if we need it, it's gonna be part of the checked version. Yeah, I think everything else remains the same, more or less. Except, again, annotated goes away. And AST representation remains. And the only thing is, I probably don't need to do that for checked. I don't think I will be reusing a lot of stuff for checked. Unless, I guess, I reuse statements and stuff, but nah, I think I would rather have a completely dedicated thing on the output. Which is kind of weird. I have two faces that use the exact same structure and one that doesn't. That's fine. I probably don't even need to keep that. Ah. Let me think for a second about this. How do I make that clean? Do I keep this? Do I keep this third phase? Is there anything I want to keep that is distinct, that is just always going to be parameterized by... No, I don't think there is. I think check doesn't make sense here. I can just remove it entirely. Okay. So, some things will move to past, some things will move to resolved, some things will remain in common. Most of it will remain in common, actually. Module will probably just be in past because we don't need, we don't need imports and stuff that's purely as part of the past phase. So that can go away. This will remain only in the past phase. path and role will need to be there as well. One big thing is I currently have role here. Role will now no longer be part of the output of the analysis phase. It will be purely a implementation detail of the analysis phase. So this all goes away. Yes, that remains the same. So now role becomes something that is actually part of the resolved stuff. That is now an implementation detail of the resolved stuff. Okay? Do I need to have that as part of this? I think I do. Because I need this constraint. Yeah, okay. So it means unless I move those as orphan instances in their own files, which is probably better. Yeah, let's do that. In which case, I don't need to do the AST phase thing, and I keep that as a type and just do a pure type family thing. So that means here, everything where I have this will become instead purely a phase argument that is purely a type, okay? So this can go away. And this will go in the past version. So here, everything here goes away. And now there is a data past, which is just a type that's purely a here for the representation instance there. Okay, where the path is a non-empty identifier. There we go. And for resolved, we go here, we go to the top, and the AST representation of resolved will be this role thing. Okay. Purity probably goes away. I think I don't need that anymore. Because I think, well, I will probably want to reintroduce it at some point, where the idea is during the analysis phase, we collect purity information that is then used during the optimization phase. But given that I'm rewriting the entirety of the analysis phase, kinda, I think we can just get rid of it for now, and we'll get back to it when that's required. Typed expression is something that is completely going away. That is no longer something that is required. So all of that goes away. Okay, so what do we keep in common that is used across both the parsed version, where we get as the output of the parser, and the resolved version, where we have only done name resolving and nothing else? Wait, is there any reason why we cannot do the name resolving on its own? I don't think there is. I think we can always know the names in scope, because all the paths... It requires a traversal, but I think that's fine. Okay, So, definition by phase that remains the same. Type alias info remains the same. Enum info remains the same. All of those things remain the exact same. I'm not going to change any of them. Just going to keep some spaces there for readability, I guess. So here, okay. So path info will remain the same. I will probably be able to remove a lot of those equality or and stuff instances, because since none of the checking will be performed, none of the type checking nor field checking nor anything like this will be performed as part of this, then a lot of those things will no longer be required, which is nice. Function type, function archetype, statement can stay with block as an alias. Annotated goes away, I think. Because I think annotated becomes simply with location for all of this. Yes, that's good. That means I remove the need for weird lenses there. That's always good. Okay. Okay, so this doesn't change. I might go back to just because this might be a lot easier. So this is the original expression. It hasn't changed. I keep it the way it is because it maps to how we pass things. And yeah, I think it makes all the type stuff a lot easier because it means rather than doing all of the complicated nonsense with type checking that I was doing, because I was doing partial type checking for generic functions, now when I do instantiate a generic function, I can know that it's instantiated with concrete types, and therefore I no longer have to do any type checking with non-concrete types. But the name resolving will remain, so I remove the need to keep scopes for generic functions. Yeah, I think if I manage to make it work, this is definitely a straight upgrade compared to what we had before. Okay. I might remove this. Plated, I don't think I need in the context, in this context. Okay, so that should be everything for the common stuff. So what is in past? Everything that is module and import goes here. I'll clean this later, because that only makes sense as part of the stuff that hasn't been resolved at all. Type expression doesn't make sense here, and none of that is specific to the past phase. So all of that goes away. There we go. The definitions of the module are with location of the definition past. Okay. And now I can go to resolved. And now I will have this. Do I need to change anything here? Do I want to change? do I want to change this? Like, do I want to break down this top level declaration? I probably do, actually. That being said, no, because I'm going to keep only a name for indirection at this phase, and as a result, it will need to be resolved afterwards anyway. So maybe what does an identifier point to in a given scope? A top-level declaration with a given name, a built-in type with a given name, a built-in function with a given name. Maybe I don't need to keep built-in function as a separate thing. Because built-in type makes sense as a distinction. It's not something... Yeah, maybe built-in function makes sense purely for the error messages. Type parameter. The name here is purely used for distinction, and I might not need that, but like what type declared it? Placeholder, function pointer as a type. Yeah, the type of something can be function pointer, and that's fine. That's a different kind of type, I suppose. Function argument. And the let variable, which is in turn a type here. A path info resolved, do I need to keep that? Yes, I suppose I need to keep that. That is what a type is at that stage. Okay. So the role remains. This enum role from constructor role will definitely require some documentation, but it can remain here. And nothing else is specific. Oh, I need the data resolved here. There we go. And I think nothing else remains of this. Oops. For the sake of keeping things, I'm gonna keep that for now, and just in case I've ended up removing something I shouldn't have removed. But now the AST is purely... Do I even need to keep the AST import? Is there anything I want to keep out of this? Like, what do I need to export out of this top level thing? Probably not much. I guess I can import past, and I can export the module. Okay. So none of this is going to compile. None of this is absolutely going to compile. But we should have cleaned a few things. Now, I should also check to see... Yes, I do have a boot file because of role. Git grab source. Huh. I don't seem to have a need to import name as... So I can probably remove the boot file. Which is always good. We like removing the boot files. Now that means it's time to go back to stages analysis, and we are gonna have to break it down completely. That's gonna be basically two subphases. There's gonna be resolving and checking, and those are now gonna be completely different, to the point where the monads we use across them will just probably no longer really, like the thing we're using at the moment might just not continue to exist. That is basically a rewrite. It's in here. Probably remove the HIE files for now. Um, what we're gonna want to do is have first a resolving phase that solves all the name but doesn't perform any check, but takes care of creating the scope for everything. So it maps, it is a simplification, it is a significant simplification version of what we have today. And then we have the checker, which will perform the second stage, which will be basically everything we have today but the resolving. So I think let's make that so core HS boot will go in old for now. Remove core. There we go. So let's make resolving. Resolve and make dir check. Let's start with the resolving phase. Which also corresponds to what we have at the moment in this kind of, a lot of this will have to move into the analysis phase, into the resolving phase. Okay. So let's copy all of this and let's get started with that. So here, this is going to be a bit different. For this phase, we need all of that. We need the symbol cache and all of those things. We might not need all of them. We might be able to simplify things there as well. But we will need, for sure, the module name, the module, and we will output some diagnostic and maybe a hash map of identifier to definition resolved. And I think we might not even need any of the definition cache and so on for that phase. Because this is purely about resolving things. So I guess it's enough to know, oh, this thing points to that top level identifier in this particular module. So this, it might be enough to just have that. And we are not returning an interface. We are purely returning the resolved version of our definitions. Which means creating the scope. Okay. Oh, this is in from core. Okay. The downside of doing this is if I'm doing all the resolving first and then all the checking first, it means I'll get all of the errors for names across a module and then I'll get the type errors for the things. I suppose it's a downside of this approach. Which means I'll get all of the errors for a module about like, this name here doesn't make sense. And then I'll get, unless I do something where the analysis of a module does take a definition, does the resolving and the checking on it, so we get all of the errors for it in a row. And then, yeah, that might be a good idea, actually. That might be a good idea. So maybe this resolve module doesn't make sense. So maybe I'll need to keep some common monad across the different things to be able to run both in the same monad, basically. So let's have a look at what this would entail. Because resolving will be basically given some declaration that has been passed, should give us a declaration that has been resolved. That's the whole point. We perform the name checking on that thing. And now, after we're done, all scope information is no longer required. That's just done. Now the question is, how much again do I need of the... What monad do I need to do this in? This is going to be in some resolve M monad at the end for sure. And this will require some context around it. Maybe you can even say it's a monad resolve M. And that's some kind of monad there. Okay, let me think a tiny bit about this. What will I need for the resolving? The only thing I think I need is the scope, basically. I only need to keep the scope thing. So I need the top level scope, which if I go back to how things were declared, if I go to analysis old monad, what's the scope again? Where is scope defined? Is it not there? It's not there because it's part of the interface, which will no longer be the case, which will be a lot better. Yeah, that's what a scope is. So I think, yes, resolving will be given some scope. Is it been... can I just get that from the top level scope, which probably will be as part of monad resolve? This is not definitive. This is just me like thinking out loud. It will be something that has access to the top to a scope, basically, which is the top level scope. Or do I need to bother about that? Can I just give it as an argument? Maybe I can just give it as an argument. The scope will be... Yeah, I think I just can take it as an argument. So that's the scope, that's the top level scope. That's a mapping of all names in scope to a given... That's a mapping of all names in scope to something, to a role, which is enough for me to replace everything in my AST. Would it be enough to just do that? Would it be that trivial? Because all of the difficulties in the name checking and everything has to do with the... All of it has to do with actually checking what is being pointed at. Maybe this is enough. Okay, so let's go back to core. Maybe I'm not going to touch core at all. What am I doing? Let's go back to common. Oh, this is definitely going to go away. Okay, let's do this. I think this is going to be a lot easier to do, to rewrite, basically. Do I want to keep a state? I probably want to keep a state. So I might want to do this and resolve for some scope and some definition will be a run to eval state T or something. Like this is going to be some monad M. We'll see what things I require. Eval state T, flip of that to put the scope. And what I'm going to do is just an action which is going to be resolve definition or something like this. That's the interface, that's the API. And now resolve definition for some I probably don't even need the monad there. I can probably let's write something. Let's figure it out as we go. So I will probably just need the definition past. And I will need, oh, actually, I can put that in the AST file. Export module past resolved. The output will be a this will be some kind of monad M at the bottom of this. This is going to be a state T of a scope on top of M on top, and the value will be a definition resolved. What do I have in my old analysis monad that is required for the state of things? That's some of the monadic, that's the absolutely horrible error handling that I want to rewrite anyway. The context is, what is the context? Okay, there we go. That's the thing for a function. That's the scope. That's the thing I need. That's the name of the function that's useful to have. The resolving. That could be in a reader. That doesn't change. The current location. That's useful. The function type is used. That's for type checking. I don't care for the resolving. That's for type checking. I don't care for the resolving. Or do I? No, this is purely when I'm trying to instantiate things. I don't care in the context of purely resolving things. Or when trying to instantiate a function. So I really don't care about that. And within loop, I wanted to get rid of it anyway, so I don't need any of that. So let's make let's copy some things there. Yeah, let's copy so little of it. Okay, so I will be doing the resolving phase. This will be done. I think I want to figure out the diagnostic thing at a later stage. So I think for now, will be purely given some underlying monad M that probably will require to have some, will need to have some monad diagnostic capabilities or something like this. This will be purely a state T of resolve context on top of M. Or do I want to put stuff? Probably want to do a reader T resolve info on top of that. There we go. So run resolve will be given some resolve info and and everything we need. Or perhaps I'll just like take the name of the function, the top level scope. Do I need the location? I probably need the top level location. The top level location. Is there anything else I will need? I don't think so, actually. Given that, and given some kind of resolve context, some resolve MA, or maybe do I remove this M suffix from my monads? Maybe I don't need to use this notation. Oh, sorry, I had missed your message. Thank you. Yeah, I think I'm gonna drop the M suffix from my monads. I think that's fine. So run resolve will be probably some mix of given some name, scope, location, action. Will probably be action and run reader T with something which will be the resolve info, whatever that is, and flip exec state T with some resolve context, whatever that ends up being. And as far as I can tell, the only thing I need for either of those, the resolve context, is going to be purely the name. I think that's the only thing I need, and I guess I can put the location as well, so I know where it was declared. maybe that's going to be useful for some error messages. And the resolve, oh, that's the, yeah, context. And that's the info, yeah, info. And the resolve context will be what's going to be modified over time. And that's going to be the current scope, the current location. I think that's basically it. I'm being overkill by naming those. That's probably going to be that simple. So given name, scope, location, the resolve info is the name and the location, and the context starts with the top level scope and the location. Okay? That's about it. So resolving will be given some top level with location definition passed and some scope, and I will need the name. So I have scope, name, and I have the with location. Oh, I need to be careful. Location is something that I can't name, so that conflicts with something else. That would be the location, and that will be the value, which is the definition. Then this will be run resolve with name, scope, location, name, scope, location of an action, which will be resolve definition of the definition. There we go. And the result will be a with location, the definition resolved, which means I just need to wrap that back. So I get the resolved def and I return. I guess I could, yeah, I can do a traverse on the definition resolve, I suppose. So instead of doing this, that's the definition right there. And I'm gonna extract the location. I don't even need to do that, I think. Yeah, that's overkill. I can just do a traverse resolve definition with the name, the scope, and the location of the definition. On the definition. There we go. Resolving a definition is going to be a very basic case. So this is going to be now in my resolve m definition resolve. And this is going to be, I can go back to my AST. It's going to be one of those. And it's basically going to be given one of those. We're going to do a resolve the thing of the info. Like this is almost, if I had, I don't think there's a good way to do this with lenses, but this is basically, if I found a way to express all of those types in the AST as some kind of like functor over the path, could I do that? Could I re-express the entirety of the AST as a... Because then it would just become a traverse, basically. But I don't think I want to do that because the scope has to be modified by the statements. I mean, yes, I could, but I don't think I want to do that because then like I just doing a traverse, just delegating to that structure for the traversal would lose the fact that I need the. Yeah, I guess I could, but I think I prefer in this case the whole reason why I'm doing this refactor is I've made a constraint, a somewhat constrained choice that has boxed me in something that didn't work for me. So I think I prefer to write things very explicitly with an explicit case that just delegates, even though it's going to be verbose, but just because it makes tweaking things if I need them to a lot easier without boxing me into a specific structure. So let's go. Resolve type alias, resolve enum. Actually, resolving enum, there's nothing to do, I think. That's probably. I can probably. Let's go back to common, which I already had. Is there anything? Yeah, it doesn't need to have a parameter that is common to all of them, because an enum info doesn't absolutely require anything based on the phase. That's convenient. So that's just creating an enum definition of the info, no need to do anything for the resolving phase. There will be a need to do something for the checking phase, I think. Because we will want to do the basic checks of like, are the names consistent? Are there any issues there? Like, do they shadow anything? Actually, shadowing might be part of the resolving, but checking will take care of the enums. At this stage, we do nothing. Resolve struct, resolve const, resolve function. Resolve type alias will be somewhat straightforward. I hope it's going to be something somewhat similar. We have our type alias info here, and we return a type alias info as output. And since, again, this is not where we do any checking, resolve type alias is going to be purely do a check of the current scope, get the thing there. If it's not something that exists, return an error. We might want to figure out what returning an error means in this case. I really don't like the monad I'm using for diagnostics. I wanted to redo it anyway. This might be a good time for that. But I guess I can delegate that to later. I can do that later, in a sense that I can take as an argument a type alias info that contains the stuff I need, and what I return is a new type alias info that contains the alias name unchanged, the alias parameters unchanged, and I almost want to write this as a lens, because this is purely what it is. Because I am traversing alias value with resolve name, which is going to be the thing at the core of this that does, okay, I have a path, give me, so resolve path, and will give me the corresponding name. That's going to be the core function at the core of all of this, and that's the only place where we're going to need to do error handling. So I'm going to later decide what the constraints on M are and how to do error handling. And here, I think there's not really a point in trying to recover, or maybe there will be a point in trying to recover. I don't know. At least not for a type alias, for sure. So we're just doing that. I think it's just that. That's purely just that, and it becomes, yeah. Okay. For resolving a struct, do I want to do some recovery between fields? Do I want each field to have like some kind of we can recover from this? The way I'm using the monad diagnostics at the moment is very ugly. I don't like it, but it is like this for a very specific purpose. But I want to think more about it. I have this very horrible thing where I keep some booleans in my scope, which is very bad. But basically, what it allows to do is it has some way of recovering, like try that gives me a maybe value, like did we fail, and but like then resumes the execution afterwards. So there is a recovery mechanism, but that keeps track nonetheless of did we have any error at all, so that we can at the end decide whether yes we have recovered, but do we keep this value or not? Basically, like how did we have any errors? I don't like this at all. I want to rewrite it. So maybe this is a good time to think about this. For instance, for structs, do I want to be able to say, like, oh, for this field, the type doesn't make sense. For this field, the type doesn't make sense. I think so. I think I want to be able to recover. So I think I will want to have some kind of try. However, that still means I am unable to construct a thing at the end. So that still means I need to have something that then short circuits again, as in like I cannot complete this. Okay, let's think about let's do the thing where like I write the code I would like to have, which then defines my API, and then I'll change my underlying monad so that it reflects the API I want to have. I think what I want to do for type alias will be the following. Let me put the AST back here. Actually, I want the past one, I think, the common one. I want to see what a struct info is. So for a struct info, it's going to be basically the same thing. I just want to apply a lens on the thing. On the struct values, I want to apply a function that, given the thing will perform, so given the values will perform some monadic action, that will be doing for each value. So for the values, which I guess is just a traverse, and for each pair of field name, field type, which I guess no, because okay, I was gonna say it's a traverse of, I can do a traverse of a traverse and get the whole thing. I think I want to get the values. I want to get the values because I want to do some recovery. So I have the values. I will get the resolved values by doing for each of the values where I get the field name, field type. So field info. I will be doing a traverse on the field info where I will be doing a try of resolve path. The problem is if I do that, I will get the maybe. I will get the maybe within. Yeah, I don't want to do that. I want the value to be the maybe to be at the top level, I think. So instead, I'm gonna do that as. So that's a tuple field name field type. I get the maybe thing. So maybe resolved type is gonna be try of resolve path of the field type. And I will be, since that's the maybe value, I will be doing pure of the field name inside the resolved type. Now I have here resolved values is a corresponding non-empty, maybe, it's a non-empty maybe? Ah, that's annoying. Do I need to sequence that? I probably need to sequence that, I think. I guess I could do it with a double traverse if I were to do a double sequence on it afterwards. Something like sequence, sequence. No, doesn't work, does it? No, it would be fmap sequence of sequence. That becomes very ugly very quickly. Because if I do a traverse of resolve of try resolve path on the values, now I have a non-empty sequence of tuple of field name and maybe values. So if I then yeah, we need to fmap ff sequence. That's kind of ugly. Yeah, I could do it with something like this, but I think writing it down is a lot cleaner. Because now I have a sequence of maybe values, and it is not impossible that non-empty has a cat maybes, basically. Which is basically what I want. Doesn't have a cat maybes. Ah. Is there a cat maybes that's... Nah, it has to be on list. There's no way to have it on a... Oh, but have I defined a cat maybes in a prelude? I have not. Okay. But unless I'm mistaken, it should just be if I have just 4 at the beginning of a list that contains just 3 and nothing else, that's a non-empty list. If I sequence that, I get that, and if it contains a nothing, I get nothing. That's just a sequence. Okay. Which means if I keep this logic that decomposes everything and does the try very manually, so I don't do the traverse, which is a bit more verbose, but here I can just do a sequence on the resolved values. That gives me a maybe non-empty thing. And I can probably do some kind of like ensure or something. I was like, okay, I have recovered from this, but here I need to go back to failing because I have something that doesn't work. Ensure. And the result of this will be and that will give me the value. Okay, so that should work. Provided here, so I'm making the assumption I have try, that gives me a maybe value, and I have ensure that gives me takes the maybe value and returns some A in the monad, but short circuits, basically, like handles the error. That's the assumption I have about error resolving. Okay. Constants are gonna be relatively simple as well, I think. Because the scope is only gonna come in play for really for functions, which are the bulk of the difficulty. So there's no scope changing in constants. So that's gonna be const info. Past, we are gonna get a resolve m of a const info resolve. Resolve a constant is going to be. Here we have two different things. I can't do the lens thing I've been doing for the others. Because here I have two different things. I have the type and the expression. And here I probably want as well to try to resolve, like if the type is wrong, I can still try to resolve the expression. So that would be basically resolved type would be a try of resolve path of the const type. Resolved expression will be a try of a resolve path, not path, of the const expression. And here I will do a lift a2 of a const info with the const name on the resolved type and the resolved expression, which will create the new const info within the maybe monad of the result. And it is enough to then just ensure this. Okay. And I guess function info is where some of the stuff becomes difficult. It's going to be not dissimilar. Resolve function. Resolve function. Like, see, this is an example of like, I don't want to make it a functor over the type of the path and then just do a traverse, because I want to decide at what level I do I want to do some recovery, which really depend on the kind of type. So writing it explicitly allows me to have that flexibility of like, where do I use some properties of the underlying monad, basically, rather than just traverse on all paths. So here I'm going to do the same thing. The function type will be resolved on its own, and I will still try to resolve the function body on its own. And how do I recover there? Yeah, I probably want to recover there in the sense of like, yeah, that makes sense. I think I want to do that. So that gives me this. How do I do this? Because that's a block, which means it's a thing of statements. I think here I don't do a try at this level. I think for a function, this is going to be a thing where like I'm going to do a for each of the statements in the function body, which has also a location. It's the same thing as here. I would kind of want to have a way to bubble the thing back up. Like I'm gonna get a list of with location of value. If I traverse, I get a list of with location of maybe value, and then I would like to sequence that all the way back up, basically. On one hand, not decomposing the things myself, like doing okay, this is a list of things that contain of things with like location. So doing a traverse of resolve statement on the wait, I'm modifying the wrong thing. Here doing a traverse of resolve statement of the fun body, and then it requires doing a bunch of sequencing. I guess I could introduce an alias for this, I suppose. Unless one already exists. Because is there something like sequence 2 that given some f of because sequence is basically this, and it gives me sequence A and sequence. Is there like a more nested one basically that gives me h of f of g of A, like a sequence 2 kinda? No, there isn't. However, if I look at the type of fmap sequence dot sequence, that is exactly that. Maybe I did? Yeah, I think you're right. That's a good point. Thank you. To closing. Yeah, it still doesn't find any, I think. But I think you're right. I was missing something there, but I still, it looks like it doesn't find any. Because if I do this and I check this, it should find maybe identity, but it doesn't even find that. Nope. The type of this should be correct, right? Like this is sequence, fmap sequence. Do I want to introduce sequence 2, basically? Like nested sequence? I kind of do. It feels like introducing one function like this whose type is readable pretty like clearly means if I don't have to do a bunch of unwrapping, rewrapping, I kind of want to introduce that function and use it. So I think I'm going to do that. I'm going to go to my prelude. This is a different kind of sequence. Nested operations. Traverse 2. Perfect. Oh, I already have... There we go. I already have Oh, but that's already the thing. That's already what I wanted, but I don't have sequence A2, which is gonna be for this basically. Given some function from A to F of f of g of b and some t1, t2 of a, you give me an f of t1 of t2. Well, an f of g. Oh, wait! That is purely a traverse with compose. That's what it is. That's what it is. That's what I want to do. Rather than doing this nested sequence, I probably just want to compose. I think that's what I think that's what I want. I don't need to do this sequence A2. Or rather, I can rewrite this exact same thing I was doing as basically being yeah, I think I could just have that with compose. Because if I have what would be the type of something that takes some function f and something to traverse and does a traverse dot traverse of compose of f of the thing and then does a f map get compose on the result. I need data functor compose, which might not be in my dependencies. Okay. The type of this will be takes a function from a f g of something. But it does give me the oh, I just want to do a get compose, not a f map get compose. Given a function from a to f of g of b, give me a t1 and a t2 of a. Give me a yeah. Okay, so that's just I can just do this with a compose basically. That's what I want to do. Okay, so that means I don't need to do this nonsense. And I can simplify this. So I can go back to this. The thing I'm applying on the values will be a traverse 2, where the thing I'm applying is resolve path dot try and compose. The try means I get a monadic maybe. I compose that as being one thing. I traverse 2. I get compose, which gives me a monadic maybe of the thing. And I f map ensure, I guess. Or do I traverse ensure? I traverse ensure. Is this better? It definitely avoids having to do all the decomposition of the lists of fields, of pairs, and things myself. Yeah, I think it's not the worst. I might keep traverse dot no, I have that alias for a reason. Okay. No, I think this is not too bad. Which means we can do the same thing here. This is gonna be on the expression here, which is a list of with location of something, which are all traversable. That becomes a traverse ensure of get compose of traverse2 of compose try resolve path of the fun body. Okay. That traverse ensure is basically the same thing as like a bind into the ensure because we're in the same monadic context. Like this is the same thing as doing this basically. What's the priority? I might not do that just because what is the... That's a 1, and that's a 9. Okay. And just to remind myself, what does each number mean? Higher binds first. So dot will bind first. Okay. So this would probably be correct. And what's the precedence of the regular bind? It's 1 as well. Okay. Yeah, I can leave it like this. It's not the worst. It removes the traverse. So here this is traverse of... There we go. I don't know. I don't know if it's more readable with the bind or if the traverse is better. But at this one, this is purely a matter of like what I find more readable. This is not, I think, a matter of... Oh wait, I don't do the ensure at this level, I think. Do I? No, I don't do the ensure at this level, so that solves that problem. It becomes that. Because here I don't do the ensure at this level. Wait, no, that's fine. Wait, no, I do the ensure at this level. Do I? No, I don't. I don't do the ensure at this level. I do a try on each of them, so I try all of them in parallel. I get a maybe thing out of this. I lift A2 this thing into the maybe, and I ensure the result. Yeah, okay. So that's fine. Okay, a lot of figuring stuff out, but that should be... The compose, I think, avoids having to deal with maybe t or a thing like this. I just compose f of maybe of something, and that works. Okay. So now we've resolved a function. Maybe function type doesn't need to be in the past stuff. No, it is because it is an argument to function info now. Okay. Oh, so that means function type is not correct. I need to... Yeah, that's not correct. So that's going to be resolve function type. Yeah, I think I want to try it at this level as well. Like, I think, yeah, try is basically like if something has, like, it has failed, recover nonetheless. Yeah, I think that's the right thing to do. So I will need a resolve function type, which is going to be the same thing. Oh, I see a mistake. This is a function info. This is a function info. So I might as well copy all of this, because this is a function type. This is a function type. And this is going to be given some function type. We're going to do something very similar to what we've been doing in the previous ones. I'm going to, for the return value, this is going to be, I can do it with compose, I think, just so that for the parallel, that's a get compose. Here, since it's already a maybe, I might want to be smarter than this. Yeah, this is just gonna be a join, an fmap join of traverse of resolve path of the function return type. And the resolved arguments are gonna be a get compose. Is my function archetype actually traversable? There is no reason. It's not. Of course not. It's not. Okay. Because it's not a functor over the path info, which kind of would make sense here. But I don't want to change that. So this becomes a traverse to get compose traverse to compose try resolve function arg of the function arguments, and the it becomes this, but in the right function this time. It becomes that for the function arguments. And we do indeed lift a2 function type. That's a function info right there. With the function name. There we go. Here this is a lift a2 the function type. The fun parameters that are not resolved, the resolved args, and the resolved return. Okay. We are missing resolve function arg. Which is going to be a very basic case of if it's by value and I have a path, is by value of resolve path of the path. And if it is by reference, will be a by reference of that. And here, no try. So if this fails, it will have to be caught by something above because there's nothing to resume. Okay. Resolve function arg is a function type. We're done with functions. For functions, we've done the statements already. The only thing we have left is expression. And this is where, I'm wrong already. There is one thing that is wrong, and that is the function here. Because when I start a function here, I will need to, and that's also the case for a type alias, I will need to change the scope to put things in the scope. Because for both type parameter and for both type alias and for function, some of the name resolving will be like, hey, there's this t thing in the argument to this struct. What is that? That happens to be a type parameter, and I need to be able to know that. So that means I need to be able to add to my current scope the things I am currently resolving. So that means I am going to need to have, I need to rewrite this first. So resolving a type alias will require, I don't think this is the case for const. There's no type parameter. There's nothing that changes the scope. Struct there is, type alias there is, and function there is. So all three of those, I need to change what I've done. And functions, there's also, of course, the arguments. So I was already wrong. So let's rewrite this. This is taking a type alias. Let's write it down. This takes type alias info. And we're going to do here there's no point in doing any try. If it fails, it fails. That just happens. So this, the resolved value will be a resolved path of the alias value. But before we do that, we have to expand scope with the alias parameters. And after that, we can do a pure of a new type alias info that contains the alias name, the alias parameters, and the new resolved value. Okay. And for structs, I'm going to do the same thing of decomposing them. Again, expand scope is vague because here I'm just giving a list of identifiers that I expect to be type parameters. So I need to be more specific with type parameters. Nothing wrong with being verbose. So here, when I resolve a struct, I'm going to do the same thing. I'm going to take as an argument the full struct info like this, decompose it, do expand scope with type parameters of the struct parameters, and I will return something that is I could here do the same thing of like use the lens. Nah, it's fine. That's going to be the resolved values, and that's going to be, why is it called values for a struct? Should it be fields? Weird. It's fine. This will be an ensure of get compose of traverse to of compose try resolve path of the struct values. And as a result, this will be pure of a new struct info containing the struct name, the struct params, and the new resolved values plural. Okay. And for a function, I need to expand the scope with type parameters before I resolve the type. And then after resolving the type, but before resolving the expression, I need to expand scope with function arguments, which are going to be the function args, or whatever it's called. It's part of the function type. Oh, so I need to give the resolved type then. But that means I cannot resolve the function body if resolving the function type failed. So I don't need to try here because I don't need to recover. If this thing failed, I cannot resolve the function body if resolving the arguments failed. So, okay, so if resolving the function type fails, I don't attempt to do the thing. So here I don't need an ensure either, which is nice. Okay. So expand scope with function arguments, and that will be the resolved arguments, which are all coming from, which will be the fun args of the resolved type. Get the resolved expression. And I'm still going to do here an ensure. Because I want to do the try per statement. And then at the end, if this worked, I return a function info that contains the function name unchanged, the resolved type, and the resolved expression. There we go. Okay. So now, before I move on to the expressions, let's add... Maybe I'm going to put that in the resolving monad. Which means here I'm going to put the resolving stuff. Where are they? Okay, so I will want to have lenses for resolve info and for resolve context. And using those lenses, I will want to add expand scope with type parameters, which is going to take a list of type parameters. Do I need to do some checks here beyond? Yeah, I guess all the checks for naming probably belong here. Because that's just a list of identifier. And that's just a resolve M unit. It doesn't do anything. But I think this will have to be some kind of monad diagnostic. Oh, that means this can fail. Which is fine. Okay. And this will be very similar to something that already exists. So I'm going to go and steal it from the thing that already exists. Okay. So that's something along those lines, but this already implies a bunch of things that I don't have with my new approach. Um, so that's basically I group and sort the parameters. If I get an empty group that makes no sense, that's just a bug in the group function, but I still want to handle that case so that the compiler is happy. Otherwise, that is a fatal error. So that's something where we short circuit. And I think I want to rename those functions while I'm at it. This is going to be, I'm just gonna do that. That's report error. And here this is report warning. Wait, no, that's report error. Oh, yes, that's the thing where like, ah, yes, I see what I had done. Fatal is the thing where like, fatal is like, I need to stop. Report is just, I can just continue. Yeah. Ah, yes, that's why I have so much complexity in my error reporting monad. Is sometimes it's like I want to signal an error, so the thing must not be able to be built at the end because it will have failed because an error has occurred. But I can still build a value nonetheless, which is weird. Which is why I have some complexity there. Okay. The problem with that approach is that I end up doing a thing or like I have to manually say like, okay, we need to ensure at this point that the thing actually worked, which like I think I used to have a validate in this somewhere. How do I want to do this? I know I'm stacking more things on top of the other things as usual, but do I want to have a thing where I recover from errors? Like I signal errors that are not fatal. Like this is an error and I just want to continue. I think that's too risky. I think I shouldn't be doing that. So if I shouldn't be doing that, that means I should go back to my try and ensure approach of like, if I want to report more than one error, then I need to try some of the errors to be able to recover. And therefore, execution can just stop on an error. Yeah, I think that is the correct approach. Which means the downside I see is that the difference between an error and a warning is purely. So I guess I just keep fail and report. Report is something I can continue, fail is something I cannot. So here, fail, because that's an error, and I cannot continue the analysis past this. Ah, this is the thing where I get the current name. So that is, oops, I am modifying the wrong file. So yeah, I'm gonna keep this fatal thing. That's fatal as well. That's a reserved identifier. I cannot continue with this. The current name is no longer called that. It's gonna be in the scope, the RI name. Where's it again? The role is type parameter with the name and the identifier. What am I doing here? I'm doing resolving a path gives something. So lookup path, I guess, is something that I need. Lookup path identifier. Okay. And then current scope is modified, but at the moment, since I only have the one scope, that is just, how is it called again? It's going to be the context scope, so the RC scope. Oh, there's something that is wrong here. That's not the end of the world. I am going to need to remember. I need to remember. Core can go away. In resolving, when I'm doing the statements, statement, where are you? Oh yeah, that's wrong. Here I'm gonna change something. I'm actually, oh yes, that's because I've copied something from the function. Because that's a function body, which is a block. Instead of doing this, I'm going to do a resolve block of the fun body, because there are gonna things I'm gonna want to do per scope. Like the scope is gonna be scoped per block, basically, which is where I'm probably gonna have to figure out some way to do some kind of finally, which is gonna be interesting. Okay. We'll get there when we get there. Because one way to guarantee that is to do a try on the thing and then an ensure on the thing to throw again, which is the poor minds finally, basically. Yeah, that's just my way. That's just what it's going to be. I need to do some kind of finally to be like, okay, even if an error occurred and we're currently not returning a result, I need to be able to unwrap at the end of the block. So yes, I think block is the correct approach for this. Okay. Which means resolve block needs to happen next. Do I have the block alias actually in common? Probably do. Yeah, I do. So I can just say that this is a block passed, and that returns a block resolved. So resolving a block is gonna be actually, since I'm probably gonna want to do a try on each thing, I don't need the finally because I will have to do an ensure on the result anyway. So I can do that myself. So parent scope. Do I want to make the scope? Do I want to like do something where I restore the scope, or do I want to do something where I just stack lists? Like I have a list of scope and I just look at the current one. Might be easier to just do it this way. Parent scope is the use scope. Then for each, so the statements, the resolved statements is going to be for each statement, which is a with location something. So that's a with location location statement. What do? We set the location to the current location, and probably want to do it back in this. So that's the location of the statement, and then I traverse do I want to do a compose again? Or will a sequence be enough? If I traverse with a resolve statement of the statement, then I get a with location of the maybe thing. And I just need to sequence that, I guess. So that's just a sequence of traverse resolve statement of the statement. There we go. And I probably want to try that. Yes, so that's try of resolve statement. At the end, I have here a list of maybe value. And so my result will be after this. Since I've tried after all of them, I'm always in control. I can always do RC scope set back to the parent scope to discard all of the changes that have been made as part of the block. Like all of the let stuff in this block is now ignored. We get back to the parent scope, and I will ensure a sequence of the resolve statements. Okay. Resolve a statement. It's going to be, as usual, a resolve M of a statement into a statement resolved. And that is back to a much more simple good old case of thing. Yeah, I'm not gonna use that. Let's use the common thing. Let's use this. All those have some info. I'm just gonna write it manually because I'm gonna make that a bunch of. There we go. And then we have the easy ones. That's pure a continue statement. There's nothing to resolve. That's pure a break statement. There's nothing to resolve. And then expression statement. There's definitely something to resolve. For an expression that is purely a resolve expression, I've named it I'm gonna name it resolve expression explicitly. Do I have any other? I don't. Okay. Resolve expression of that expression. Oh, except that is a with location again. So I probably want to do the current location is the location of that expression, and I resolve. Wait, no. Wait, is it? Oh, it is, but I think I'm gonna make the resolve expression take the location in thing, so I'm just gonna do this, I think. Okay. Break statement, continue statement. I am not gonna check them here. Something I discovered during the IR lowering phase is, since I have to do all of the control flow analysis as part of that phase, this is a very good place to do that kind of stuff, because I will need to know where is that break going, where is that continue statement going. That is the perfect place to do that kind of check. There is no need to do them as part of the analysis. So let's do that. The only downside of not doing it as part of the analysis is generic function instantiation, as always, where, like, if a generic function that is fine on all regards except for a break or a continue is instantiated in a third-party module, it will break on that when actually compiled, when actually lowered into IR. Maybe I can keep the check. Yeah, maybe I should keep the check in the checking phase just to avoid that. That's probably fine. Okay. So, what do we have? In the case of a return statement, we have a maybe with location expression. Okay. Is that purely a traverse of resolve expression of the info? I think it is, because we don't need to do any try or ensure at this point. And the resolve expression will be taking the... yeah, I could have done the same thing here, where resolve statement takes the one with location. I think it's fine to do it like this. Okay. Let statement, all of those will just become resolve. It's going to be an if statement of resolve if of the info, or statement resolve for of the info, while statement of resolve while of the info, and let statement of resolve let of the info. Again, very verbose, but I think I prefer this. This needs to be wrapped back into a return statement in the same way that this needs to be wrapped back into an expression statement. Okay. I'm gonna keep expression for last because it's gonna be the most complicated. resolve if is going to be take some if info, past, and return that. Oh, I saw a typo. Statement. If info resolved. Okay. So here we're gonna do, it's gonna be very similar to what we've done so far. I get a if info, I decompose it, and I do. I think here all three need to be, so resolve the expression will be resolve expression of the if expression. And here, do I want to try? Yeah, I want to try that, I think. Resolved body. It's going to be a try of a resolve block of the if body. Resolved else will be a try of the resolve else. It's going to be a join. It's going to be a traverse. Try resolve else of the if else, because there might not be one. And the result will be ensure of a lift. No, it doesn't need to be it is a lift A3 of an if info with the resolved expression, which is a maybe. The resolved body and join of the resolved else. Wait, that's not true. That is tricky. If I do this and I do an ensure there, I need to make sure that I don't fail when there is no return value here, when that thing is nothing. I need to be very careful here. Otherwise, an absent, if I just do a join, a non-existent else will be treated as an error there. So let's write it down. If I have nothing, that means there was no return, which is valid. If I have just nothing, it means error. And if I have just, success. I don't think I can. Because if I sequence nothing, nothing's going to happen. Like sequence and nothing, which is a maybe int, is not going to give me a just nothing. It does. How does that work? Because it's using the foldable. traversable. Okay, so in this case it works. So if I sequence the result, if I don't join, but if I sequence of the nothing will give me just nothing, so that's correct. If I sequence of just nothing, I get nothing. And if I sequence of just 3, I get just 3. Okay. So it is a sequence that I want. Perfect. Not a join. So sequence worked the way I was expecting. That's good. So I guess I could put it here actually. Sequence of that, and that becomes the resolved else. Okay. Resolve else. Resolve else is straightforward. We have some else info. We return some else info. And this is a very basic case. If it's an else if with some info, we return an else if of resolve the if of that info. If it's an else block with a block, we return the else block of resolving the block. No need for try at this stage. Perfect. Next. Next. We're done with if. We can move on to, I think it was 4 as the second. 4 is going to be very, very similar. So I'm just going to copy if. Resolve 4. It's interesting. When I started this project, I thought, oh yeah, the analysis is going to be long, but it's going to be easy. But the lowering into AR is going to be a nightmare. The lowering into AR was as close to trivial as anything has ever been in this project. And the analysis, I'm back on it because I have to change things because I've made so many mistakes in it. The complexity is not always where you expect it to be. So here, we do the same thing again, except the variable name doesn't need to be changed. So the only thing I need to change is the expression, which is the 4 range expression, which I'm going to try, and resolve block of the 4 body. And this is a lift A2 of a 4 info that takes as first argument the 4 variable name and the resolved expression and the resolved body. I need to be careful. I am making a mistake. Okay. I am making a mistake. I need to... Which I think I haven't done in my current version of the analysis because we don't have range expressions just yet. I have not done. So I need to expand scope before I resolve the body of the for loop. I need to... that's the problem. Okay. That is the problem. Resolve. If I do this, when I come back from resolve body, the block will have been the scope will have been restored, but will have been restored with this, which is incorrect. So I will need to change resolve block to take as the first argument some action in the monad that sets things in the block. Initialize, well, update scope, basically. So I get the parent scope, I update the scope, And then at the end, I restore the scope. There we go. So resolve block now requires and here I can do that with the argument to resolve block being this, which is expand scope with function arguments. I'm just gonna make it a bit more readable, like so. Block, there we go. Resolve block here. For the if body, there is nothing that needs to happen. That's a pass. There is no new variable that needs to be set in the scope. The scope will need to be restored at the end, but there's nothing that needs to belong in it. Same thing here. I'm just gonna do that. And here for the for body, that's gonna be the same thing again. Do I have a try? Yeah, I have try on the other ones. So here I'm gonna do the same thing for a for loop where I'm gonna resolve the block, and the first argument will be expand scope with variable. And the variable will be, do I need to know its type at that point? Resolved. Let variable identifier path info resolved. I do need to know its type. So I will need the name, which is the for variable name, and the type, which is I don't know the type. I don't know the type because I have not resolved the type of it yet. So maybe because yes, I haven't done any type checking on the thing. So maybe here that means that I will need to not keep the type here as part of that. A let variable is just an identifier. Because otherwise I would need to be able to guarantee that I have the type information that I just might not have. However, I can there you go. I can say maybe path info for resolved in case there was some. There we go. And here there will be nothing because I have not done any checking. I don't know the type of this range expression. Okay. We resolve the block. There we go. Now we can go back to, after for it should be while, I think. While info, and the while contains an expression that we try with resolve expression, which is the while expression here, and it contains a body. And here there's no need to do any expand with variable or anything because there is nothing that makes it into the body. So it's just with pass, and it is the while body. And that becomes a lift a2 of a while info of a resolved expression and a resolved body. There we go. I think that's all. If I look at all the resolved stuff, definition, okay. Type alias struct const function, type alias exists, and I'm missing path. Structures. One of the ones I've done. Path is missing. Resolve path. Oh, I probably need to also check. Since this is the part where I do name resolving, that means the next phase will have to assume the names are correct. This means I guess there are a few more things I need to check here. The name of the declarations will be handled by the thing that calls this, I suppose. Or maybe I'll do a resolve module on top of this that will take care of that. Is there any other name I need to check? Oh, I haven't done the resolve let, I think. Yeah, I haven't done resolve let. Because I think variable names and functional arguments are the other thing I need to check in terms of name, purely. Let's look at function arguments. Analyze a function. There we go. Analyze function type. Oh, well, I don't seem to be doing that. Or do I? I don't do any shadowing or anything. I don't do any check like that. Okay, well, that's a thing we can fix. So I need to check for any name I encounter that the name doesn't shadow any existing name in the scope and doesn't use a... Okay, I can do that. I can do that for the names here as well. I guess... Here I have the thing of the placeholder. How do I handle this? Because basically placeholder is only valid in some cases. And what that means is basically placeholder should be in the scope only in some cases. So I need to look at when I've been saying allow placeholder, and I need to put that in scope, basically. Because otherwise that won't work. I guess I can make that as an argument to resolve path, like decide each path individually whether a placeholder is allowed. Which is probably going to be no for most places. And it's going to be only valid in expressions, I suppose. I think placeholders are only valid in expressions. Because they are, I think that's the only place they are valid. For the type of a let something, that would make sense. Do I accept it actually as for a let at the moment? I guess it's not an expression, so that it's already... Else if... What do I do for a let? I do allow placeholder. Okay. So I guess within the function it's allowed, but never outside of it. Ah, it's not for a cast. That's interesting. So I think rather than putting it in the scope, I think I'm gonna make it a special case. I'm gonna make two different resolve path function. One of them allows for the placeholder in this context, and one does not. I think that's the right approach. Okay. Let's look at all the resolved path I have so far. In a type alias, no. Placeholders are not allowed. In a struct type, no. In a constant absolutely... constant type, no. I think. Yeah. In a function argument, no. Oh, wait. That's resolve function argument here. In the function return type, no. In a type alias, no. In a struct, no. That's all of them. Okay, so it's purely in expressions, and then it's just not in all of them, just a lot of them. Okay. Okay. What am I missing? I need to do the let. That's one of the things I'm not doing yet. Oh, yes, I'm not adding... No, I am adding function arguments into... Oops, not there. Function arguments. Yes, okay. Expand block with function arguments. I'm doing that. I guess I could do that with just like a variable, basically. But no, I don't want to do that just because I think resolved. Yeah, it's function argument, not let variable. Okay, so yeah. So we do function arguments. Was there any other modification to the scope I was forgetting? Oh, checking the validity of function arguments. That's the thing I'm not doing. Okay. I wanted, actually, I'm going to do that for a second. Because the shadowing I'm doing for type aliases. Where did I put that? Did I put that in the monad? Yes, I've done that here. I can put that here, I suppose. That's a helper for... I think for now I'm not going to put this one in here. I think I'm gonna do something, check for duplicates, which given a list of identifier gives me a list of identifier to know which ones to report. So check for duplicates is going to be a map maybe. Am I right that a fold of a just a fold of a list into a maybe is just the first argument? Wait, what am I doing? No, that's not okay. No, that's not correct. Not fold. What am I doing? Maybe to list is what I want. No, list to maybe. But I'm certain that list to maybe is implemented as just a very basic other thing. Where is it defined? Maybe. list to maybe. Is implemented as a fold, but not a regular fold or something a bit more complicated. Okay, I'm just gonna use list to maybe, that's fine. So this is gonna be, because head is not, that removes the report ice, which is nice. Okay, so it's a map maybe, a list to maybe of, that's not true actually. That's not that at all. It is a map maybe of check group of after group, where check group is a case. Oh, actually, group sort. There we go. It's that. Where in the case where it's empty, we get an empty group. That's a bug in the group function. There is not much that we can do about it. If we find more than one, that puts that list, that puts that identifier in the list. So I am gonna do maybe just that identifier. And if it's just one identifier on its own, that means the group only contains one element. That's nothing. Okay. So check for duplicates. No, not check for duplicates. Find duplicates. Okay. So that means first we do an ensure of a sequence of what I'm going to want to do is I'm going to want to do something for each. So for each, find duplicates of the parameters. Okay, so for each of those which are the duplicates, we do a try. Well, I don't like doing a try fatal like this. I don't like doing that. Because the goal here is basically I want to report all of them without failing. That means basically I need to try. Yeah, I think it's not the worst. Let's try ensure basically. Try a fatal basically. Immediately do that. And that's an error duplicate type parameter. Which I suppose I can rewrite as a traverse with try fatal error duplicate type parameter of find duplicates of the parameters. There we go. Okay. Next. Next, it is an ensure of a sequence. Wait, is that correct? Is that an fmap sequence? No, it is that. There we go. And that is the same thing here. Ensure sequence of I might not do it this way. Okay. Let's not do this first. Let's do this first. This is for each parameter. Try, check, void, try, check. Not void. Result is try of check. Validate. Because I'm not in the checking business just yet. I'm not in the business thing just of checking just yet. Or do I want... No, I think everything naming should be checked as part of this phase. So that would be a validate validate name of that identifier, or validate identifier, I suppose, to be consistent. And the result of this would be putting pure identifier, pure parameter role. Ah, that's annoying. That is annoying. I was gonna basically try to move this check of like, is it reserved? Is it shadowing something into a separate function? So I don't have to duplicate that stuff when I am checking for like variable names or something. But this requires the role, but that should be fine. That should be fine. Okay, so I try to validate the identifier, and the identifier will require its role. So binding, I suppose, because it is the identifier and the role. And if it is valid, I can do that in the result. And I get, and then I make, so I will probably move the from list afterwards, I think. It's going to be the bindings. This is going to be, so I'm going to be traversing a thing of identifiers. I'm going to obtain a list as a result. a list of maybe values, which means I will need to do the classic ensure of a sequence of this nonsense, where that's the result and that moves into a separate function. Okay. Which means now I can use this as a function called validate binding that takes the identifier, the role, and does that basically. When it is reserved, and of course we'll return some maybe, so some resolve m maybe unit. No, actually just some unit. When that identifier is reserved, throw a fatal error. I need the name for... No, I don't. That goes here. This goes here. It could even go here. Okay. And here, so, okay, when the identifier is reserved, then that's a fatal error. When trying to look up a path, give me a list of names that already exist, I report shadow for those names and the identifier and the role, I guess. I'm changing my diagnostic. Warning name shadow is going to also contain the identifier there. There we go. And that is not fatal, that's fine. And if we made it that far, return nothing. Use the... I don't even need to do that when just M should do it for me. So that gives me... The try gives me a maybe unit, and I override it by this. Okay. So now I can go back to my other expand scope functions with function arguments and with variable. Function arguments takes the list, and with variable takes variable name and type parameter. Okay. Expand scope with function arguments. Yep. Function arguments, and that takes... Sorry, let me just check that. Okay. This takes a list of function argument resolved. Is that function argument? Is that something else? Function argtype. Wait. No. It takes that. A tuple, a list of tuple of identifier function archetype. Okay. And it does something very similar to this. And I suppose I have an error duplicate function argument in my diagnostic. Duplicate error duplicate function duplicated arg. There we go. Which is not great because I have duplicate type parameter. Okay, enum duplicate entries, struct duplicated. Yeah, that's a bunch of inconsistencies. So enum duplicated entries, struct duplicated fields, function duplicated. That should be entry then, if the others are singular. Duplicated field, duplicated arg. And this should probably be declaration duplicate type parameter. Or duplicated type parameter just should be enough. Okay. So that's a bit more consistent. So duplicated type parameter. And here, oh, well, in here, in function arguments, this will be error function duplicated arg. And this will be on find duplicate of map first of the arguments. Which is the reason why this block is not the same, is duplicated across this function and not part of validate binding. Then that is basically the same thing, except the role will be function arg. That is part of resolved now. Function argument identifier and type. For arguments, that's the identifier and that's the arg type, which I'm gonna rename arg name here for readability. So the role is function arg type with the arg name and arg type. Then we validate the binding by checking the arg name and using the role, which is something that we didn't do before. So that's when this all compiles is progress compared to where we were when we started, which we're not yet. We put that in the maybe by using the result of this try there. And the scope is expanded by adding the union, by doing a union with the hash map created by doing this list of bindings. And union always takes the ones on the left first, and those will be, well, the left-hand side of union, but that's the case, so they always override with whatever is there. Okay. So we good? Wait, is that correct? Yes, it shadows. Ambiguity, shadowing removes ambiguity because my scope contains a list of things that match with that name. So I can be like, oh, you called foo. Which one of those did you want to call? That's an error. But if an argument name shadows something else, then using that argument name is not an error because there is other things. The shadow overrides, so this is fine. Okay, so expand scope with function arguments, that's done. And we have, I think, a third expand scope with variable, which will take, it's going to be basically the same thing. Just going to copy that. Except it takes instead the identifier and maybe the path info resolved. Because we might not have a type for that thing yet, given that we haven't done any type checking yet. With variable, var name, var type. Here we don't need to do I might not need that actually. Yeah. Here we don't need any of the duplication check. So here this is purely, I don't need to do any try, this is purely a validate binding with the name and the role, where the role is gonna be let variable. Var name, var type. We validate the binding. If it's validated, we modify the scope by doing a union with a list, which is a singleton of that var name with the role. Okay. What else am I missing here? So that's all the validation. I'm going to be missing the resolve path, of course. So I've done resolve while and so on. I'm missing the resolve let, which I think is one of the few cases where we're going to allow a placeholder in something. Of all the things we've seen so far, I think it's the first one. Resolve let info, let info. Steam. Nope. Let's go back to common. Let info. There we go. So here we're going to need to resolve the type. So it's going to be the same thing as what we do for a return. Wait, not for return, for a function type. Which is, wait, actually, let me check something. Yes, that's correct. Okay. So, aha, here I have fmap join. We have said earlier that's not correct. That's a sequence. Where have I used a sequence on the maybes before? There was a thing that we could have. It was the else, wasn't it? Yep, that's what it was. So the function return was wrong for the same reason. Okay. So that's what we want. So here for a let, the type will be wait. What am I saying here? I was wrong about. So this is a try of a resolve path, which is why I do the sequence here, because that gives me a maybe, which means that for function return, here I need to do the same thing. This is try, and this is resolve path, not resolved. To the point that I'm wondering if I should do a get compose. Just for the symmetry, so that it's more readable. And avoid having a bunch of sequence when I can just compose instead. I'm going to do the same thing here. Get compose of traverse with compose. Okay. Here I have a fmap sequence, but that's the one I'm currently doing. Okay. So let's do it this way. Traverse compose try resolve path of the fun the let type. Okay. The resolve expression will be a much more straightforward try resolve expression. A much more simple, okay, resolve expression, and the let expression. The result will be ensure of a lift a2 of let info with the let name of the resolved type and the resolved expression. However, here first, if this succeeds, so the ensure has guaranteed we have a value. So at the end we can do a pure result, but we will have short-circuited if actually so I have a try on every statement in a function. The idea is, okay, if there's something wrong with a statement, we can still try to recover and see if there's anything wrong in further statements. The problem with this is if a name is wrong, but since I have done an ensure at this point, if I've done a try, it means I should always add the name of the variable to the scope as long as it's fine, so that I can so that further statements can be checked and still know like, oh, this variable here points to this one, even if they failed to check for other reasons. That way I can guarantee I can avoid weird errors. Okay. The only trick here, let's just hide this for a second, because what I'm going to do is going to be the expand scope with variable. I will want to ensure that. Because I done 2 tries. Yeah, I guess the only reason I can't do... The only reason I could not add the variable to the scope is if it's wrong in the first place, which is fine. So I guess what I need to do, and I need to be careful, when I am back after those 2 tries, can I add... Aha, yes, I can, because it's fine to add with a maybe type. Okay, so here I can do expand scope with variable, put the let name, and the resolved type, which is a maybe type, which will always be there if resolving the wait, is that correct? No, I want to do with the content of this, because this is a maybe type at the moment. It is a maybe type, I think. It is a maybe type, and I want to only add this using the thing is, I think it's fine to try to add it to the scope even if the variable doesn't exist, because the function will not compile anyway, but it will remove wrong errors. So I think here it is fine to do this. It's fine to do this, I think. because it's fine to have nothing, to add nothing, even if like that would be wrong. And then here I can ensure this. And since this could throw, then yeah, okay, I think this is fine. So now we're done with resolve let. And I think we've done all the scope manipulation we needed. Every block that is open add its own new variables in the scope, and block takes care of doing tries and everything to guarantee that the scope is restored. Let and others put new variables. We've added more checks than before in terms of name and other things. I'm going to move actually find duplicate and validate binding. I'm going to move as like a separate group of functions at the end here, because those expand scope are the things that manipulate the scope. There we go. So we are done with statements. We've done all of the statements, I think, because we've done let, while, for, else, if, which is if, for, while, let. Yeah, that's all of them. I think the only thing we have left to do only is resolve expression. Which is going to be tricky, but hopefully should not be monstrous, because again, we are splitting between the resolving phase and the checking phase, so now this is purely resolving. Okay, so this should be some monad M, which is going to be actually monad diagnostic or something like this, but we'll do that in time, because we're also rewriting all the diagnostic stack. It's fine. This will be, therefore, an expression a with location expression passed, and this will return a resolve M of an expression resolved. Okay. Resolve expression is going to be doing update the location to the location of the expression so that we have better error reporting. And then this is going to be just a case of the actual expression within, and this is going to be a doozy. This is going to be that. However, this should not be too monstrous, because none of this results in new names being added in the scope. None of this requires tries and errors, so this should actually be somewhat straightforward. Famous last words. So a path expression is the very thing that we want to actually solve. I'm just going to also do a quick thing just to save me some time. Oops. There we go. This is going to be therefore a path, and this will be a path oh, actually, I could be smart. Let me just pre-fill everything with what it's going to be, because everything here is a bunch of non-spaces followed by a bunch of things. And what I'm going to want to do is replace that by Something along those lines. Oh no, it didn't. Okay. That's fine. And now I can just do... Wait. What are you unhappy with this? Oh, because it's a query placed, not a query exp. There we go. There we go. Okay, that's pre-filled with the basics. So we have a path expression, we can resolve the path. Path expressions cannot contain placeholders. That makes no sense. Field access expressions have a left-hand side and a right-hand side. And they are... do I do a lift or do I do that? I think I prefer lift A2 of field access expression. Resolve expression of the left-hand side and pure of the right-hand side. A call expression has a path info on the left-hand side where placeholders are allowed. This is a rare one. And a list here, so args instead. And this, I'm going to open a do block instead. The left-hand side will be... the left-hand side, so resolved LHS is going to be a resolve path or placeholder. No, actually, it's not true. That's not true. That's not true. That's not true, I suppose. How do I distinguish the fact that the type name may contain placeholders, but the top level thing must not be? I suppose this will be part of the check. I am allowed to have a placeholder as part of this. Because so far I've just made resolve path and I haven't made any check. Do I want to just always accept placeholder for now and filter it out afterwards? Maybe that's the right solution. Maybe I do the placeholder checking as part of the checking. Yeah, maybe that's the right solution. Maybe that's the right solution. And resolved args will be... Here, I don't think I really care about trying within an expression to try to do any recovery. So that makes it a lot easier because the arguments just become a traverse resolve expression, which means I can just actually do it this way. This is a call expression of resolve expression of the resolved path of the left hand side, and I'm going to do it with a lift A2 there again. Call expression of resolve path of the left hand side and traverse resolve expression of the arguments. Array expression is just a list of expression that is a traverse resolve expression of the expressions. Index has a left hand side and a right hand side. This is a lift A2 of index expression on resolve expression of the left-hand side and resolve expression of the right-hand side. Struct expression has a path, which is the name of the struct, which is expected to be a type, where placeholders are allowed, but this is not where we're going to check them. And a list of fields. That's basically this. Struct expression. With the path and traverse with the fields. A Boolean literal expression is just that, no transformation required. An int literal expression is just that, no transformation required. A character literal expression is just that, no transformation required. Likewise for strings. That we don't handle yet because we don't handle arrays yet. That's basically what it is. We have a reference expression with a path. There we go. Okay, an int negation expression has just an expression, and it's an int negation expression of the expression. That's basically the same thing for a Boolean negation expression there as well. An addition is a left-hand side, right-hand side, and it's that of resolve. It's a lift A2 of that. Resolve expression left-hand side and resolve expression right-hand side. Okay. And for a lot of those, this is going to be for a lot of those, this is going to be for most of those, this will be replaced by lift A2 of that and resolve expression left-hand side, resolve expression right-hand side. Okay, let's go over them to make sure I have not made any mistake. Multiplication, division, modulo, exponentiation, equality, difference, greater, lesser, and so on. Okay, Boolean and Boolean or. All of those are just resolved left-hand side, resolved right-hand side, and then lift the result. Cast, however, is different. That's the expression, and that's the cast type. And that's an expression, and that's resolve path of the cast type. Then that's two arguments, that's fine. And then I think everything else is good. Okay. And that should be the end of the resolving phase, which we have separated from the old analysis to just do name resolving, but without doing any check. And that should work because it is always possible to create the role for every top level definition. So finding like, okay, this struct point to this struct and so on is always doable. Because we have the level of indirection, there's no like cycles to worry about or anything like this. Then we have our scope management functions. The only thing we're missing, I think, is resolve path. And I think we will need to make sure that in the built-ins, we will probably want to have a built-in identifier. Yeah, we already have it. Pure underscore is placeholder. There we go. So that's already done. So I think the last thing we need to do is just the one function that binds all of this together. I might actually define as part of the monad. Here, because resolve path is something that takes a path and it returns a resolve m role, I suppose. Well, no, this takes a path info passed and returns a resolve m path info resolved. I guess this actually is just part of the resolving stuff. That's not a special function yet. Because we get a path info, which has the path name and the path type arguments, parameters. Params, there we go. Here, there's probably no point in trying to do any try. There's no point in, like, if the name doesn't resolve, the arguments will probably won't resolve either. I guess I could still be like, no, you're calling a struct that doesn't exist, but the type parameters, type check, or vice versa. Maybe no, actually, I might want to do that a try. Okay, so that will be... This will be the actual resolve name, or resolve identifier. The true resolve, basically. How do I want to name this? Because this is also called the path. I'm just gonna call it resolve name. That gives me, that's the true function at the core of it. Resolved named name will be a try of that. And the parameters will be a get compose of traverse with compose of try of resolve path of the path params. Okay. And then we can do a path info, a lift A2 of that, with the resolved name and the resolved params, and we can ensure that result. Okay. And resolve name is going to be the one. Resolve name is going to be taking an actual raw path and we'll return a resolve m roll. And that's gonna be done with let's do a lookup of that path name in scope. So this is gonna be a use the scope, and the function I'm applying on it is a lookup of the path. Actually, I have used in resolving, I've used a lookup once. Lookup path, there we go. Lookup path might be, I'm gonna rename a lookup name, and that's gonna be pure identifier. There we go. Lookup name is gonna be the one here at the core of the thing. Lookup name, and this one returns a maybe. It returns a list of role, I suppose, because a scope non-empty role. But the maybe non-empty role, that's basically the same thing as a list of role. But I guess what do I want that to be? I think I want that to be a maybe non-empty. Yeah, I think I want this to be like the raw maybe non-empty list of role. Although that's isomorphic to a list. Because I think here, yeah, that's convenient to have that. So that's the very basic thing that does the lookup in the thing. I might even want to, no. Okay. And that means that I am moving resolve name here at the very bottom of the file, and we're done with everything else. Resolve name. Resolve name for a path does lookup name of the path, and then deals with text, probably. Get type name. No. Resolve path, there we go. This is what I want. This is what I want. I get the roles, which is always non-empty, by doing, and which is therefore decomposed into one role and the other roles, by doing a lookup name of the path. If it gives me nothing, then I report an error, role not found. And otherwise, if we have found a role and maybe some others, if the others are not null, that's an error. The path is ambiguous in the current scope. here's the list of all the rules that match. Otherwise, pure roll. Okay, and that should be the rewrite of the resolving phase, which is the easy part. I'm gonna order some food, and then the food arrives. I'm gonna take a break for some food, and then I'll be back to continue the refactor. So give me 1 second to place an order, because I know what I want. Because now we need to basically rewrite the checking phase, which takes this resolved thing where all the names are already known, but so it's going to be a lot of the same things, but simplified. Give me 1 second. What do I want actually? I want that. Actually, do I take a break even to order just like an actual break? I'll take a break for 5 minutes to just do the order, and I'll write more code while the order is on the way, and I'll take a real break when the food arrives. Be right back. Okay, let's go back to this. I'll take again a break, a real break for good. I'll stop the stream for real when I will be taking a food break. But for now, there's a tiny bit more I can do. There's one more thing I want to do as part of this resolving phase, and that is taking care of the top level stuff, as in doing all the name checks at the top level. Although I guess this doesn't need to be done in the resolve phase, it can be done at the top level of the analysis phase, which means this should be all for the resolve, come to think of it. Okay, because scope computation and everything is going to be done by resolving the imports and everything. So maybe, yeah, okay, now I have a definition and I can fully resolve it by traversing it. Okay. Okay, therefore that should be all for this. It's kind of annoying to have just a separate file within with the monad there. That's kind of maybe I should just inline this in there. Like the resolving can be just that, basically. The only thing we need to export is resolve. Because there's very few places where I use RC or RI something. But if I do that, I probably want to keep the monad in a separate file just because of lenses. Lenses are a pain in the ass otherwise. So any function that uses them needs to be after. Therefore, any function, yeah, okay, I'm gonna keep it separate then. Resolve statements, all of those are the resolve, and this is scope manipulation. This is name validation. Ah, there we go. So that should be all of the resolve phase. Perfect. So now, in the analysis here, oh, I've modified diagnostic here. Diagnostic will have to be moved out of here, I think. I'm gonna kill this. I'm gonna move it back. Yeah. I'm gonna read back here. Diagnostic is something that will go beyond the analysis phase, so it needs to be moved out of there. So it's probably gonna become in part of the internals or something. So I'm gonna move it out of this part of the code. So now, time to do a check. Do I want to rename this resolve? Maybe I do. That being said, most of the name of the stages have been names. It's not assemble, it's assembly. It's not pass, it's passing. So maybe resolving. Maybe resolution, actually. Yeah, maybe that's better. Resolution. And let's move check to validation. And so we can start validation here. And validation. So resolving doesn't exist anymore. This is resolution. Just gonna copy all of this. Actually, it's all wrong. Here, as an argument, resolving a definition. I don't think that's the only thing I will need to do. Um, because I will need to do resolve on a few things, but I will also need, that's also the function I'm going to use for like the actual instantiation. Do I actually need to instantiate? Like, do I have more things to do for things that will not survive the analysis phase? I think the answer is yes. I think I need to do more than that. But that means, that's annoying. That means maybe I need to do a, I can't do a just check function that takes a definition, and I need to do one per different thing because I will be doing different things, checking a type. Yeah. So that will be, I will probably have instead one check function per kind of thing. Because the type of what I want to return will be completely different per top level thing, I think. Yeah, okay. So let me think for a second. I will not need to check type aliases. There's no need for that. I think. What do I have in my old core that no longer exists for a type alias? Yeah, it's just resolving it. I guess no, there is some stuff to do actually. So I will need to be able to do, okay. So I will need to figure out what kind of information needs to be present in a type alias. And I will need to figure out what kind of intermediate representation I need for this. My food is on the way. I'll stop the stream for now. I'll be back in like half an hour. See you then.